Ever wish you could make your pricing like super agile? All right, so ETL, I think a lot of folks out there are really looking to kind of, wrap their heads around it, and we're going to really unpack it all today. So we're talking nuts and bolts, what makes it tick?
Right.
Why is this such a crucial piece for, getting actual value out of data?
Absolutely. It's I always say ETL is kind of like the foundation of a house. You can't really build anything meaningful on top of it if you don't have, a good, strong foundation. So you got ETL stands for extract, transform, load, and it's the process of taking raw data from all its various sources and turning it into, something structured and usable, for analysis, for reporting, or even for training those AI models that everyone's buzzing about.
So it's more than just like, moving data from point A to point B. It's like,
Right.
It's got to be, there's more to it, right?
Yeah, it's not just about moving it. It's about, refining it, preparing it, getting it ready. I like to think of it like baking a cake. If you just had flour scattered all over the counter and eggs cracked in random bowls and sugar still in the bag, you couldn't bake a cake that way, right? You have to, measure it out, sift it, mix it all together, and get it ready, to go into the oven. And so that's kind of what ETL is doing, is taking all that raw data and getting it prepped.
Okay, yeah, that's starting to make sense. So, we talk about data. It's coming from all these different places. We have databases and applications and sensors. Oh my.
Oh, yeah.
How does ETL even begin to wrangle all that?
Yeah, that's where data ingestion comes in, which is the extract and load part of ETL. And it's really all about understanding how to most efficiently get data from those, diverse sources and move it into, a central location, whether that's a data lake or a data warehouse.
So are we talking like, copy and paste files, or is
Sometimes.
it more than that?
So sometimes it can be that simple, just transferring a spreadsheet from one place to another. But in a lot of cases, it's way more complex than that. We might be using APIs to pull data from a web application. We might be, setting up some kind of scheduled data dumps from a database, or even, tapping into real-time data streams from sensors. And so the method really just kind of depends, on the volume of data, how fast it's changing, the structure of the data, all of that.
So this is making me think about like those meal kit delivery services.
Yeah.
All the different ingredients, they come in all these different packages, but they ultimately have to come together.
Yeah.
So was that kind of what we're talking about here?
That's a great analogy. Yeah, you wouldn't want like your fragile herbs shipped in the same box as, potatoes, right? They need different handling. And similarly, we need to select the best data ingestion technique, based on each individual source and its characteristics. So, APIs are really great for accessing data from cloud applications, while file transfers might work well for moving large data sets less frequently. And message queues can handle those constant streams of data, like sensor readings, without getting overwhelmed.
So it sounds like choosing the right ingestion method is key to ensuring data quality.
Oh, for sure.
Right from the start, right?
Absolutely.
So okay, now we've got all this data coming in, it's landed at its destination. I'm assuming it's still kind of messy though, right?
Yeah. Yeah, that's where the real magic of ETL happens, which is the transformation stage. So it's like, we've gathered all of our ingredients. Now it's time to clean them, prepare them, enrich them, get them ready.
So we're going from a jumbled grocery bag to neatly chopped veggies and pre-measured spices.
Exactly.
That's
Like
nice,
that.
right?
Exactly, yeah. So we might start by filtering out irrelevant data, like discarding a wilted piece of lettuce. Then we'll clean the data, correcting errors and inconsistencies, like maybe standardizing dates or removing duplicate entries. We can enrich the data by adding valuable context from other sources, like maybe incorporating demographic information to customer data. And finally, we might aggregate data to get those high-level insights, like calculating the average customer spending per month.
Okay, so it sounds like there are a lot of steps involved in this process. What kind of tools are we using to accomplish all of this data transformation?
Well, there's a whole toolbox available. And the choice really kind of depends on the complexity of the task and the skill of the data engineer. So, programming languages like Python with its pandas library are incredibly versatile for data manipulation. SQL, the language of databases, is essential for working with structured data. And then for really massive data sets, we might turn to powerful frameworks like Apache Spark, which can distribute processing across a cluster of computers.
Okay, so Spark, That sounds impressive.
Yeah.
Why is that the go-to for like, really huge data sets?
Yeah. Well, Spark's ability to process data in parallel across multiple machines is a real game changer for big data. I mean, imagine trying to chop a mountain of vegetables with just one knife. It would take forever, right?
Huh?
Spark's like having a team of chefs, each working on a portion of the ingredients simultaneously.
So it's all about speed and efficiency when you're
Yeah.
dealing with that
Yeah.
volume, right?
Absolutely.
So we've got the data, it's prepped, it's, flowing through the pipelines. But, how do we make sure all these different steps are happening in the right order at the right time? I mean, we wouldn't want to like try and bake a cake before we've mixed the batter.
Right.
How do we coordinate all of this?
Yeah, and that's where data orchestration comes in. It's like having a project manager for your data. It ensures all the different steps in the ETL process are executed in the correct order at the right time and with the necessary resources. And that's what we're going to tackle next.
Perfect. Let's dive right into that.
All right. It's really about coordinating all the different tasks involved in the ETL process, right? And making sure everything runs smoothly and efficiently. So you're not just scheduling tasks. It's much more than that.
Right. It's more than just like a to-do list, I'm guessing.
Exactly. Yeah. Think about like, a complex recipe where you have multiple components that need to be prepared, in a specific sequence. Some steps might depend on others. You can't floss the cake until it's baked and cooled, right? So data orchestration manages these dependencies, making sure that each task has what it needs before it starts.
Okay. So it's like, we're understanding those relationships between those different tasks and making sure that it all flows together.
Yeah.
How do we actually go about mapping this out, managing this sort of complex dance of data?
Right. Well, we use something called DAGs, which stands for Directed Acyclic Graphs. And they're essentially flowcharts that visually represent the steps in our ETL process and the dependencies between them. So each node in the DAG represents a task, and the arrows show the order in which they need to be executed.
So days are like a bird's eye view of the whole entire workflow, right?
Yeah, it's a great way to visualize it.
Okay, so what about execution? What are the tools that we're using to make sure all these tasks are happening according to that plan?
Yeah, so that's where orchestration tools come in. Think of them as like the conductors of our data orchestra, making sure that every instrument plays its part at the right moment. One popular tool is Apache Airflow. It's been around for a while, so it has a huge community and tons of features, making it a really reliable choice for a lot of organizations.
So Airflow is kind of the veteran in the orchestration world, right?
Yeah, pretty much.
Are there any like newer tools that are coming out?
Oh, absolutely, yeah. Tools like Prefect and Dagster are kind of shaking things up with modern approaches and really user-friendly interfaces. So they're gaining popularity, especially, for teams that are working with complex data pipelines.
It's great to see that innovation in this space. What are some best practices that we need to keep in mind no matter what tool we choose? For data orchestration, what are we thinking about to make sure everything runs smoothly?
Yeah, one crucial concept is backfilling. So imagine you're setting up a new ETL pipeline to analyze customer data, but you also want to include historical data. Backfilling allows you to process that older data and bring it into your new system, ensuring you have a complete picture from day one.
So backfilling is like catching up on all the episodes of our favorite show that we missed, right?
Yeah, exactly.
Oh.
Another one is idempotency. So that means that running a task multiple times produces the same result. Like, imagine if you accidentally ran a data transformation twice. If the task isn't idempotent, you could end up with duplicated or corrupted data.
Right. So we're really trying to ensure that consistency of outcome,
Totally.
especially when we're dealing with, critical data.
Yeah.
But, sometimes things go wrong, right? What do we do in those situations where our recipe, so to speak, goes awry?
Right. And that's where things like retry logic and fallback mechanisms come in. So just like a good chef can improvise when an ingredient goes missing, our orchestration tools can help us recover from errors and keep our data pipelines running smoothly. For example, if a task fails, we can configure it to retry a certain number of times before alerting us to the problem.
So we're talking about resilience here, right? Making sure the systems can kind of handle those hiccups, those unexpected events.
Yeah.
But, we're dealing with a lot of data here. So how do we make sure our systems can handle that that scale, that growing volume.
Right. And that's where efficiency and scalability become, really crucial considerations in ETL. So that's what we'll explore next. We'll look at how to optimize our processes and infrastructure to handle, even the most demanding data workloads.
So we've got our data prepped. It's moving through our pipeline.
Yeah.
But as we talked about, the volume of data is just, it's exploding.
Yeah.
So how do we make sure these ETL processes can really keep up and handle that scale without everything crashing down around us?
Yeah, well, that's where understanding efficiency and scalability become crucial. It's kind of like if you imagine upgrading your kitchen to handle a banquet instead of just a simple dinner party, right?
Right.
We need to think about both our resources and our processes.
So it's more than just, like faster computers.
Yeah, I mean, it's certainly part of it. We might need to invest in more powerful servers or, even leverage cloud computing so we can scale our infrastructure on demand. But it's also about optimizing the ETL processes themselves.
Okay, so what are some of those techniques that we can use to make the ETL processes more efficient?
Well, one approach is parallelization. So, imagine having multiple chefs working on different parts of the meal simultaneously. In ETL, we can break down large tasks into smaller chunks and process them in parallel, across multiple computing cores or even multiple machines, and that can really significantly reduce the processing time.
So we're kind of dividing and conquering the data.
Yeah, exactly. Yeah. And another powerful technique is data partitioning. So instead of treating all the data as one, giant blob, we can divide it into smaller, more manageable chunks based on certain criteria, like, the date or the customer ID. And this makes it easier to process and analyze, specific subsets of data without having to sift through everything.
So it's like, organizing our pantry with labeled shelves and containers instead of having everything just piled in a big mess.
Right, exactly, yeah.
But what about storage? I mean, as data volumes grow, obviously storage costs can really start to add up.
Oh, for sure. And that's why we need to be smart about how we store the data. Techniques like data compression can help us reduce storage space without sacrificing data quality. So it's kind of like using space-saving vacuum bags to store those bulky winter clothes, right?
I love that analogy. That's great. So we're, finding clever ways to manage those resources. We've been talking a lot about technology and optimization, but what about, the human element? How do we make sure our data teams are all working together effectively to build and maintain these, very complex systems?
Yeah, that's a really crucial aspect that I think is often overlooked. Collaboration and a positive developer experience are essential for any successful ETL project.
Mhm.
We need to create an environment where our data professionals can really thrive.
So what are some of those key ingredients for, creating that kind of healthy, productive data team culture?
Well, communication is paramount. We need to break down those silos between different teams, like the analysts and the engineers and the business stakeholders, and really encourage open dialogue. It's, if you imagine like your chefs and your bakers and your prep cooks all working together seamlessly in a kitchen, sharing tips and ideas, that's the kind of collaboration we want to foster in our data teams.
It sounds like a recipe for success.
Yeah.
What else? How else can we support those data professionals?
I think providing the right tools and resources is essential. We need to choose technologies that are intuitive, easy to use, and support collaborative workflows. Clear and concise documentation is also crucial so that everyone understands how the systems work and how to contribute effectively.
So it's like having a well-equipped kitchen with a detailed recipe book.
Exactly.
That everyone can understand. But, even with all that, with the best tools and the best processes, sometimes things still go wrong. So how do we, build that culture of continuous improvement, of learning from those mistakes?
Yeah. I think embracing a mindset of experimentation and learning from failures is really key. We need to encourage our teams to try new things, to push the boundaries of what's possible and to view setbacks as opportunities for growth. Just like a chef who's constantly experimenting with new recipes and techniques, our data teams should be empowered to innovate and refine their processes.
This has been a really incredible deep dive into ETL. I mean, we've covered so much, from the fundamental concepts to, all these advanced techniques, efficiency, scalability. But before we wrap up, I'd love to get your final thoughts. What's that one key takeaway you want our listeners to really remember?
If I had to sum it up in one sentence, I'd say ETL is the crucial bridge between raw data and meaningful insights. And And building those effective ETL systems, it really requires a blend of technical expertise, creative problem solving, and a collaborative spirit.
Yeah.
Very well said. It's like we've gone from, you know, gathering those ingredients and prepping them to creating a masterpiece meal that nourishes the entire organization with knowledge. And to our listeners out there, if this deep dive has sparked your curiosity, we really encourage you to keep exploring. There's a whole universe of data out there waiting to be transformed into something amazing.
And who knows, maybe you'll be the one to create that next groundbreaking ETL innovation.
That's all for this deep dive. Thanks for joining us, and we'll catch you next time for another deep dive into the fascinating world of data.